Okay, welcome. I'm Casey Jacobs, Director of Engineering for Microsoft.com Operations. With me today from our team is Chris St. Ahmad. He's a Senior System Engineer from what we call our debug, kind of an R&D type team within our operations function. And we're partnering up for this running Megasites on Microsoft Technology session this afternoon with Aber and Jim.
I'm Aber Whitcomb. I'm the CTO of MySpace. I'm also here with our VP of Technology, Jim Benedetto.
Welcome, guys. We've had a good time, actually, over about the last 9 months or so, working off and on, just talking shop with the MySpace.com and the Microsoft.com, and just trying to learn how to live and survive running large-scale systems, right? So today, we figured we'd share some of these with you, right? Both of us are going to give a little bit of an introduction, some just quick facts about scaling capacities that we experience day in and day out. We'll then hand it over to Aber and Jim. They're going to go into a little bit of detail about what it meant to grow up on the internet over the last few years at the rapid pace that MySpace has experienced. We're going to then follow it up with both of our perceptions on what are the upcoming technology enablers that we have our sights set on right now. They might be product technologies, they might be things from partners or different vendors. Just share how are we all surviving and preparing for that next stage of the big enterprise systems. And we're going to try and leave quite a bit of time towards the end of this as just an open panel discussion forum. There's the four of us here. We cover the whole gauntlet of business operations all the way down through your engineers running boxes, development approaches. We've got plenty of good friends in the audience as well if the topics outrange our expertise or our areas of scope within our companies. And lastly, I'd just like to promote that we want this to be an interactive session. So we prefer that if you have questions at any point throughout the presentation, feel welcome to raise your hands. We'll try and hit a few of them as we go, and we prefer that kind of dynamics, right? So don't hesitate to raise your hand if you see anything that you'd like to drill into a bit more. Okay. So kind of just a brief history. These guys are going to talk about how things really came to life over the past, 2 or 3 years, guys? 2.5 years. The Microsoft.com world really has been kicking around for about 10 years or so. And from a point where we were running on a single box in someone's office, connected with about 30,000 users, to today where we're, from a media metrics ComScore perspective, doing about 60 million unique users in the US. That's like a number 6 ranking for unique users. And worldwide, we have about 300 million unique users, and that's a number 3 overall. These guys are going to talk about some of the large-scale page view data they deal with and how that ranks amongst some of the internet providers. Our experience has changed from just have some content on the internet to today everything as you hear the whole buzz of the conference, right? It's all about being connected, service-driven. So Microsoft.com is certainly about product support, IT and dev experiences, customer intelligence of data and profiling and working with people to build a more realistic personal experience. And certainly you're probably all familiar with the Microsoft Update and download infrastructures. That's also systems that we operate and run. So you can see the evolution for us. These guys will do a comparable slide coming up here in a couple moments. Quick facts. Most people don't realize Microsoft.com isn't just one site, right? It's actually a huge ecosystem of solutions, business solutions running behind the scenes. So for the company, we work with different portions of Microsoft, much like different business organizations, like the Windows organization, PSS for support, media divisions, and each one of these is a customer to us. And that ecosystem ends up being, some 110 plus something.microsoft.com solutions. Hosted within there are thousands of applications. Chris will talk a little later about the complexities of being a hosting provider and actually running thousands of applications on a site. And behind the scenes, people often wonder how dynamic is Microsoft.com's experience. If you ask our DBAs back at home, very. Right? There's thousands of, literally over 2,000 live production database systems online all the time. We push a lot of bandwidth. We'll talk about some of the demographic, the traffic shaping practices that we handle or that we put in place to handle our cost controls. And then down below, just a couple, certainly our two biggest systems are Microsoft.com and Windows Update. Just some traffic stats around those. A lot of requests, a lot of connections. The Microsoft.com, you see lots of vRoutes, web apps, application pools. That's your classic hosting type experience, right, for us. We're essentially hosting for all the product teams, all the subsidiaries worldwide for Microsoft, so all the different country locales, and then anyone who wants to essentially spin up a site inside the company. Windows Update, very focused service delivery system. Right? It's built to do a certain function, and it's certainly high scale. We have, these numbers here show, we have the ability to reach out and touch 250 million clients a day if we want to, right? That's a pretty powerful system. It's completely ASP.NET and SQL driven with lots of caching built in between. These guys are going to really talk later on about how they've handled their scale and the caching solutions they've implemented. So at this point, I'll let Aber jump into MySpace's profile.
All right, so we've got some more bragging numbers here, but actually this is just to give you an idea of the scale and the size of MySpace that we're dealing with. 64 million registered users, 38 million unique users. That's in a month. Now, we don't have as many uniques as Microsoft.com. Our traffic is really from page views. Our users stay on for an incredible amount of time. Average number of page views per user is around 50. So it's quite a few. Most of our traffic is really from the page views, which you can actually see graphed right here. Ours is the one that's shooting up in second place behind Yahoo there.
And for you guys, that's certainly by design, right?
Oh, absolutely.
That's all the social experience.
And we're all of our revenue is driven off ads. So the more pages people view, the more money we're making.
So he's asking, how much time does the average person spend on, the MySpace.com site?
Last time I looked, it was, I think, around an hour.
Wow.
I know it was a few months ago. It was around 40 minutes, and it's probably up from that. It's a lot of time. People are addicted to the site, and when people are addicted, it makes for a pretty hard site to maintain. Some more details here. 23 billion page views, and demographics pretty much 50-50. Some trends, the way people are using the site, we're getting 260,000 users every day, and that's accelerating. And in terms of images, we have 430 million total images. So we have a huge static content infrastructure also. And loads of songs and all kinds of, and 20 million comments posted every single day. All right, some quick facts. We have 3 data centers. This is actually a picture on the right of one of our data centers. We have around 3,000 servers. I think this number is a little bit old. We make heavy use of cache servers. We have about 90 cache servers loaded up with RAM that we try to stuff as much data into as possible. 650 Dart servers, those are what serve our ads. 60 databases, and about 150 media processing servers that are converting data for us to our formats. We have a very large SAN architecture with 3,000 disks. Our bandwidth numbers right here total about 30 gigabits per second. Okay, I'll tell you guys a little story kind of about where we started and where we are today. I'm going to go through a timeline in terms of the number of users that we have registered. We initially started off with a very simple design, 2-tiered architecture. We had a few web servers on the front end and a single database on the back end. I like this architecture. It's very simple. If you can maintain a site using this architecture, highly recommend it. Your operational costs are low. You can develop very quickly on it. If you have high availability, you can have a disaster recovery site with very little complexity. Problem is, it just doesn't work for all workloads. When you start to get a lot bigger, you need to start getting into more complicated multiple tiers in your architecture. That was beginning. 500,000 users. We had our single database that we had was maxed out. So what do you do when you max out a database? Well, there's a few things. In our case, CPU is maxed out. So first thing you do is you try to tune all your queries. Get the CPU down. You get your best query tuners in there and see what they can do. Second thing you can do, you just buy a bigger box. You buy a box with 16 CPUs or 32 CPUs. Or you can use a replication technique and split out. If you have a workload that has a lot of reads and not so many writes, you can have your writes go to one database, replicate out to other databases that just handle reads. That works okay too. There's really only one solution if you don't know when you're going to stop growing. And that is partitioning. You need to start partitioning your data. You have to find a logical area where you can start splitting things up and put different data on different machines.
So in our experience, we had the same growing pains going back a few years ago on Microsoft.com. We also have a large profiling set of user and company information. Same thing, it's partitioned out into several different layers. Mm-hmm. That's exactly how we had to handle our growth years ago. This question, is that where you get your 2,000 plus databases? Actually, it's only broken into 4. So that only counts for 4 of those database systems. We host hundreds and hundreds of database, kind of like a true hosting environment for internal customers inside Microsoft. Customers is like a product team to us. Yeah, question? Difference between vertical and transactional replication?
What we did initially, our first design, or actually our second design, our first design was 1 servers, but design number 2 was an attempt to use SQL Server transactional replication to have a single master write server and then replicate the reads across all of a different form of read servers. Now, it worked out for us for a while, but eventually you've got so many writes hitting your master server that the writes alone will overload all of the servers in the farm. Step number 2 for us, or actually version number 3 for us, was what we call vertical partitioning, where we actually took the site and we spliced separate features of the site into our vertical partitions, and we had each individual feature of the site would live on its own database. And there was no transactional replication. The databases were autonomous. They weren't aware of each other, and we were using functions for the web services to know which database to go to based off what feature the user was clicking on. It was a configuration file. So we looked at using a master directory server so we could move data around and just have a single server that basically would be a dictionary to tell the web services which databases to go to for what content. We scrapped that idea because that single server was a potential scaling bottleneck.
So when you max out a single server in vertical partition, you need to, well, in our case, what we did is we looked at getting faster hardware. We would start maxing out the existing SCSI type system that we had for our back end and look to go to much larger scale systems. We swapped out our SCSI-based systems with an EMC box. You are able to get a lot more disk, much better performance. If you start seeing I/O bottlenecks, recommend you start looking at what type of storage you're using. Yeah.
You say that again?
How did you split the reads and writes?
What we did is all of the replicated databases, whether it be the master write database or all of the read databases, shared the exact same schema. We did that for just manageability purposes. So even though a database might have been dedicated as a read-only database, it still had the write store procedures on it, or the store procedures that would handle writes on it, just so we didn't have to manage multiple schemas. And then from the front-end logic, all of the parts of the site where there would be write transactions, sending mail, adding comments, adding friends. We then used front-end presentation layer logic to point those at one particular data source.
So when we got to maxing out one vertical partition, for instance, blogs. Blog was out on its own vertical partition, one database handling that particular function. What happens when you max your blog's database out? So what you have to do is you have to take all your features, bring them back into one single database, and then start chopping up by your users. In our case, we would split up in logical blocks of million users. So every time we get a new million users, we put it in that one database that has all that functionality, but it services different users.
One thing to note on horizontal partitioning is we spent a long time thinking exactly what mathematical function we were going to use in order to segment the user ranges. And a lot of people were pointing us in the direction of mod-based mod-based partitioning, where you do a mod of a mathematical number and put each user in separate buckets. We went with range-based because we didn't know how big we were going to get. And it was a decision early on, I think about 3 million users, to go range-based instead. Seemed like a risky decision at the time, but in retrospect, we're very glad we did it. If I would recommend, if you're ever looking to scale something and you don't know how big it's going to get, if you use a mod function, you'll be committing to something that you might not be happy about in the future.
Did you guys find that certain ranges are much more active? Like as you add new ranges of users, the old ranges are kind of not so busy, the new ones are much more busy?
So far, it's been pretty. A million users is a lot. So over those million users, it tends to actually get a little bit normalized. But what we've seen is that the older users tend to be just as active as newer users because you tend to have more users in the latest ranges online, but the users previous in the lower ranges are more active and more sophisticated, tend to log in more times. They know how to use the
Fair
site
question,
better.
though. His question was really, did you find risk in going with the range method,
Yeah,
right?
there's
and
absolutely
certainly
risk associated
it could
with that.
occur.
Yep. We talked about horizontal partitioning. Okay, so 5 million users. I thought I'd throw this in just because it's interesting to note. Once you start getting big enough, there's some network issues that pop up that you may have not had when you're smaller. What do you do when you start maxing out gig links? Almost every site has a single load balancer. What happens when you max out your load balancer? You have to start thinking a little bit more carefully and plan your network architecture very carefully. A good example is load balancing load balancers. How do you do it? One way to do it is to use a combination of DNS and regular local load balancers. Just make sure all your load balancers are redundant, and round-robin DNS will work just fine.
You'll see here coming up in a few slides, we'll make a note of just kind of a real-life implementation for some of our database hosting, where we use a DNS over to help load balance over those local load balancing of the hosts. Yeah.
What we did is, well, there's some types inherent in a social networking.
Yeah.
He asked what type of, you asked how we, from the front end, as a user comes in and clicks on a particular feature of the site, how we know which database to send that user to. Well, we actually had a function in the presentation layer that said, if the URL or the cookie shows that this user is in user range 37 million, then we're going to send them to range 37 million. It's not as straightforward as that because there's inherent in a social networking infrastructure, there's a lot of interconnected data that needs to be interconnected. If you're my friend and I'm your friend, I show up on your page, but I'm not in your database. So there's a lot of back-end replication and little tricks that we do. But overall, it's basically a pretty straightforward function that says, if you're in a 37 million user range, you're going to database 37.
Yeah, one more?
At what point in this process did you guys start to scratch your head and go, okay,
So
At what point in the process did you scratch your head and pull out your
every
ear?
night.
Every day.
No, yeah, there's times when you have, hundreds of thousands of users online, and now we have millions of users online at the same time. There's nothing you can do to stop them from coming on. So it's it's very sensitive, especially when there's that many people clicking with spinning browsers. You can't just stop all their browsers to make those requests. So there's plenty of times where we've said, what the hell are we going to do? And you just have to, and we're pretty much telling you, what the biggest pain points that we have. The key is just to try to plan for infinite scaling. Did I answer your question, or?
So like at 1 million users, did you guys say, okay, we need to call Microsoft and have them help us? We need to call somebody.
At what point? Let's see. I don't know if there was actually a particular point where we said we better call someone. We try to do as much as we can on our own, but Microsoft's been great in always offering help when we need help, especially when we got bigger. I think maybe around when we hit maybe 5 million, we were on their radar, and getting some good attention from guys like Casey.
Kind of on the side, to speak, I'm outside of their world, right? But we've had a relationship for about 9 months or so. Mm-hmm. And one thing that I was very impressed at, that I thought they had done an extremely solid job, is they are all over the place at looking at the enterprise vendors and partners who have really proven themselves in the market. So every time that we meet up and talk with Jim or Aber or Alan or some of the other folks from their team, I'm just amazed at how they have their hands on all these different irons, always looking and thinking about what's next. Because we're all pulling our hair out every day for something, right? I mean, when it comes down to it. And I think that that's a good credit to some of their success right now and being able to keep up. They're not tying themselves to one solution necessarily. You're looking at the product capabilities, you're looking at the hardware vendor capabilities, and you do a lot of playing behind the scenes to do your homework, right?
Definitely.
Yeah, one more question.
Yeah, I had a question similar. How do you handle it organizationally, especially in your IT organization? Did you feel like you had to bring in a lot more people, a lot more engineering talent, you had to bring in some management talent that you had to do?
Yeah.
So how did you handle the organizational growth and structural changes required as you grew up? And besides changing your titles.
Sure, yeah. Sure, Casey has some good examples too. But in our case, you have to try to scale your operations team and your development team. And on the operations side, you start to realize you're going to need full-time data center people, and you start to realize you need dedicated systems people. And I think as the need arises, you start to break up these groups and then hire managers that you trust to run them. On the development side, what we did is we had these huge product requirements, a very long list of products that we needed to develop, but we also had to try to do all the scaling stuff to keep the site up. So we would break the development team up into developers that work on scalability and developers that work on products.
I would say something similar. I mean, both Chris and I have worked in the Microsoft.com world going on over 6 years. And so about 5 or 6 years ago is when it really took off for us. And then we started hosting many other systems across the company, lots of organizational merges coming in, people and bodies. And, it's always, people always have their own opinions and experiences in this. But I think one thing that's kept our operational team very strong, when I say operational, we're at a maturity point where we've got a 100-man operational team. DBAs, web engineers, debuggers. We've got people looking at infrastructure solutions. That's your Active Directory, DNS, security-based tactics. We have network architects, and then we also have a full 24/7 NOC type system with about 100 people. Correct.
We have about 90.
I think that's pretty efficient, to be quite honest. Out of those 100, for us, 25 are what we call Tier 1 and 2 support functions. So that's really the NOC behaviors. But that's one thing. We kept our operations. Every time another organization came in or another organization came in, and you guys are experiencing some of this now, I believe, with being part of News Corp You know, they come into a bigger family, right? One thing I think that we've done well in hindsight is we didn't start to run many small ops teams, okay? Because we've seen that occur. We've seen discipline start to fall apart at the seams. We've seen that organizations that do that have potential not to share knowledge very well across one another, almost drive the wrong kind of competitiveness across the experience. So I know that today you guys are certainly still one operations team as well. But that's one thing in hindsight that I would throw out.
Yeah.
As you made the coding changes and the infrastructure changes, how did you care for the users? How painful were those upgrades to the users? Was there significant downtime?
So the question is, when we are making these major architectural changes, how does it affect the users? And the answer to that is sometimes it does affect the users. You have to, especially when you're moving data, there's really not a good way to move data while there's people writing to those databases. So in a lot of cases, our DBAs would spend very, very long nights shutting certain users off and then trying to migrate that data. So it would affect the users on the front end.
So how did you manage that to minimize the
What we do is we turn off just ranges at a time so that we wouldn't have the whole site down at certain times. We can, with the horizontally partitioned, or depending on if we were vertically partitioned at the time or horizontally partitioned, we just turns off parts of the site at a time and try to work on small areas in the middle of the night when our traffic is very low.
I would kind of, carbon copy that with our, we have a horizontal partition model for our profiling database systems, and same thing. We will, if we know we're going to roll a new version and it has the potential, or for some reason requires some downtime during the release, at the application level, we'll always try and implement versioning, right? So we'll actually have version 1 running, roll out version 2, and do a shift, a cutover, right? But at times, if we have to have a database impact, certainly we try and minimize the scope that it affects during the release through the partitioning.
You eventually get to such a point where you're facing so much production load that load testing, actually true load testing in a staging environment becomes near impossible, just because it's virtually impossible to replicate the amount of load in-house. So the best way to do it is to make sure that you roll out things in very, very small segments. So for us, a new code, a new feature, an upgrade from SQL 2000 to SQL 2005 will affect users in the 6 million range for a week, and they happen to get to be the lucky guinea pigs for that week. If it works, then we can just stage the rollout to the rest of the site.
So how do we deploy the websites? You want to go first, or
Was that for Microsoft, or what?
flip a coin?
Go for it.
Okay, we'll go first. Yeah.
How did you?
So in the appendix in here, we have a slide for Microsoft.com. Very cookie cutter model for infrastructure. Aber was talking about when they were real small. Life was great. They had a couple of hosts going to a database server. Well, in the appendix here, we kind of articulate our standard practice for every site that we implement, every system we implement from an architectural infrastructure perspective like that. But in essence, we have server web farms that run in anywhere from 3 to 8 hosts per cluster. Okay, we use NLB in front of most of those clusters. And I'll go ahead. Yeah. 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 So he's asking, when you do code changes, how do you get them out to the whole web farm, right? So that cookie cutter infrastructure footprint I just mentioned, we'll repeat that to scale out horizontally as many web farms as we need. So Microsoft.com is 10 web farms of 8 servers apiece, right? 80 servers, and that's split across multiple data centers. And this leads into now, how do you release the code, right? Okay, if we know it's a pretty seamless release, low risk from a change perspective, change management perspective, we're very disciplined about updating what we call VBS. It's just our VBS script in-house. It has every registry component, metabase, any config file settings inside that script. So every change is applied there. It goes to a staging server, and then we'll, boom, replicate that out across the entire server farm if we're very confident. If it's a much more risky release, we'll actually use our our load balancing of our load balancing, as Aber calls it, right? Where we actually have global load balancing from Akamai called FirstPoint, and we use Savis's solution called ITM. These are both DNS load balancing based solutions. And we can detail what percentage of traffic we want to go to any one of those web clusters. So we might actually remove all the traffic from the cluster that we just released the change to, dial back 1%, 2%, get our confidence up. Chris and the debug team might be looking at all the errors and making sure everything's cool. And then when we have confidence, we'll put it back to full load and then send that scripting change out to the rest of the sites. We're actually going to talk about what's changing in IS7 coming up from a new technology perspective to where we can toss out the majority of that scripting. Because to be quite honest, I mean, it's a fairly complex script that our engineers are very disciplined at maintaining. Yeah, it's just the script. So we don't use a deployment tool other than copying and running from the command line. Yeah. One more question, and we should probably keep it rolling. But again, we'll have lots of time at the end here as well. Go ahead. His question is, okay, so great, you've partitioned horizontally your database, or you have your clustering method, or whatever your choice is, right, for giving some resiliency, both from a scale and an uptime perspective. But you're running in multiple data centers, right? So how are you ensuring that you've got cross data center resiliency at the database platform level? I'm going to save that question a little bit because we have a slide coming up on SQL 2005 where we articulate how we do that. But in essence today, our cookie cutter approach on SQL 2000 was we log ship to the other data center. And if we have to, we make a decision if we need to fail over or not and recover on that other data set. Worst case, from a DR perspective, we always back those critical systems up to tape as well. So that's our generic approach. We'll be talking in a few minutes about what we're doing different in SQL 2005 now. Okay, thank you, good questions.
All right, 7 million users. You hit an issue with site dependencies, and what we mean by this is there's different functions of the site. For instance, mail and authentication. It's a good idea to separate them up into separate logical VIFs in your load balancer, even using separate subdomains. So login.myspace.com is a separate group of servers than mail.myspace.com. And the reason you do that is because the request can have different performance characteristics or could be connected to different data. Now, if one gets slow or there's bottlenecks on one or even one goes down, it won't affect the other parts. The reason for that is because if you just had one VIP, if one was down, all the threads would get eaten up across that VIP on the down server on the back end. So eliminating dependencies in your architecture really helps you manage it and improves uptime quite a bit. You usually look at most big sites and you'll see that they're using a lot of different subdomains, news.yahoo.com and mail.yahoo.com, for example. Scalable storage. Jim, I'll let you talk about this one.
One major problem that we had from the beginning and that we continue to have today is disk I/O, where we are always bottlenecked on the disk. It's the slowest part of our entire infrastructure. So for us, it was really important for us to figure out how we were going to first build an infrastructure and architecture that would hopefully eventually eliminate the need for, or at least minimize the dependency on the speed of individual disks. And second, do something that look at different SANs and different ways that we can basically scale storage as horizontally as we can scale the infrastructure that we've designed. I think we're actually going to touch on that a little bit later, but one thing that's really saved us, about 10 million users, and continues to save us today is virtualization layers above physical storage that some of the new SAN vendors are offering right now. And it's been a savior for us, and I think we'll touch on it a little later.
Yeah, a question?
With regard to the disk I/O question, what kind of things do you do around adjusting logging to address those? Are there anything you do in the logging
On SQL Server, we
So the question is, what can you do to reduce disk I/O on the back end? Can you reduce logging?
are you talking about on the SQL Server database side, or?
Talking more in terms of your just raw HTTP request to file system. Do you do anything?
We haven't had disk I/O problems on the front end tier, or the presentation layer, or the middle tier, which is mostly memory caching. For us, all of our disk I/O bottlenecks have been SQL Server database bottlenecks of MDF and LDF files.
Typically, the bottlenecks that we would run into on the front end, right, Chris, are if you've got an extremely busy system where you're in the midst of a DOS attack, we'll hit connection bottlenecks.
Most of the limitations in either hitting them in the network stack, as far as the number of connections you can handle on a box, or the rate of SYN packets coming into your site.
What kind of connections are we talking about, Greg?
Just regular, HTTP connections
What kind
sitting
of
there.
numbers?
I think the highest we've seen during the My Doom attack against Microsoft.com, we had boxes up in the 140,000 connections range. So it's a lot of connections with clients just kind of sitting there, idling or requesting bits.
And that was our critical bottleneck at that point.
Exactly.
And I think you guys have experienced the same thing. Typically, when you're talking file and web type traffic content, you have connection issues or application memory type experience issues. Yeah.
Definitely.
Okay, 15 million users. We started to come up, we started to realize databases isn't the greatest way to scale. One, they're very expensive, both on the hardware using and on the storage, and also on licenses if you happen to be paying for licenses. So we decided we needed a caching tier. And what we did is we decided we were going to stick in a layer between the web servers and the databases, where a web server would always check the cache servers to see if the data was in there first. And we did this all in memory using ASP.NET 2.0, 64-bit. 64-bit's very important because on caching servers you want to have a large memory footprint. And when you're dealing with 32-bit servers, that footprint becomes very small, especially when you take a gig or two for the operating system and then a little bit of overhead, and then you may only have a gig or two left to cache and servers.
Can I ask a question? How many folks in the audience are actually running any 64-bit infrastructure in-house right now? Well, it's pretty good, actually.
Yeah.
Good.
We'll talk a little bit more about 64-bit, but there's been a lot of areas where 64-bit architectures, software and hardware, has really saved us. Caching tier. We also put in an algorithm, an LRU algorithm, for those of you not familiar with it, least recently used. So you can you stuff data into the cache, and every once in a while it will run a scavenging algorithm that will look at the objects that are used the least, and then get those out of the cache to make room for the stuff that's getting hit a lot more. That's the best kind of algorithm for high performance cache there. And once we got this in and we were able to get our cache hit ratio up by adding more and more servers and getting more code to actually hit that caching tier, we noticed dramatic reduction in load on the databases, which saves quite a bit of money too. Yeah.
Did you consider phonotype databases or caching rather than going down?
I'm sorry, I missed the first part of that.
Did you go down the route of considering phonotype databases?
Oh, in-memory databases?
Yeah, the question is, did we look at in-memory databases? Definitely. We looked at in-memory everything from databases to potential just RAM disks, of potentially taking our existing SQL Server databases and instead of having them on fiber channel SAN storage, using them to directly connect over fiber channel to RAM disks. So Windows wouldn't know it, but we would be running everything in RAM to a variety of different open source in-memory databases. And it goes back to all of it looked really great, and it looked like it was something we could definitely use. But at the time, we were growing so fast that we stuck with let's keep it simple and find a simple way to do this and not necessarily go down the extremely experimental route if we don't have to.
You know, we were catching up a couple hours ago, and that phrase, keep it simple, came up, and I cannot reinforce that enough.
Yeah.
Right? I mean, there's all kinds of sexy solutions out there work with. And as you get bigger and bigger, the introduction of the methods of creating interruptions or service interruptions or downtime or scaling issues. We certainly have kept it simple with respect to trying to be cookie cutter about our infrastructure approach and our architectural approaches. Certainly, I think you guys have experienced the same thing. You're going to have to make decisions on changing that architecture from time to time, certainly, but it's keeping it simple. There's a lot to be said for it. Yeah, one more question. We'll move on.
The question is, how did we manage cache invalidation? And what you do is, in our case, it's all an event-driven invalidation system, because when a user changes something on their profile, they expect it to change right away. So having a sliding expiration rule, for example, didn't work for us, because if let's say it expires after 5 minutes or something like that, if a user uploaded their page, they wouldn't see it for 5 minutes and they'd keep on trying it. So it would actually make the problem worse. So you build an invalidation system into your caching tier. Recommended to actually build it into each one of the caching servers as opposed to a separate system, because it's a lot more scalable. But you can put it behind a load balancer or use your own load balancing algorithm to use a protocol to actually hit it, invalidate it, and it'll eject it out of the cache. And then you can make a decision or not if you want to rehydrate the cache at that time or just wait until the request comes through again. Okay, scaling SQL Server.
So these slides here, Aber and Jim really wanted to just have some talking points to reflect on the key versioning that they experienced. So they're in there in case you get back to the office next week or a couple weeks from now, and you're like, oh yeah, what did they say, or what were they talking about from V1 and V2? The next couple slides are just a reference to that. And you have where you are today, right? One more.
Yes. And, we stuck this slide in here that we used in the keynote. Just to reiterate what this was, this is the performance monitor from a single page on our website. This is the page when people log in and they can control their pages. They can edit their profile or view bulletins from their friend. It's their personal homepage. While we were rolling out our new ASP.NET 2.0 code, we grabbed this snapshot of it, and it shows the reduction in CPU. Each one of these bars is a server, and the blue is the CPU utilization. So as we were rolling that out, it shows how much better performance we got. We were actually able to reduce that pool from 250 servers down to 150 servers. Yes. Yeah, refactored.
So refactored code, yes.
Okay, a few questions. Yeah.
What kind of specs did you have on your SQL servers?
Was the first one was a Dell 2850, two-way, I think 4 gigs of RAM.
And then, so we noticed that SQL Server loves RAM. Put as much RAM as you can in it.
What are you running today, Aber?
We run DL585s. We use AMD Opteron 64 bits, and they're 4-way dual-core servers. So they're actually 8-way servers with 32 gigs of RAM.
Yeah, and those are actually the same. That's the same server spec that we're running on.
Yeah.
On Microsoft.com.
That is the same server spec. We've also been looking quite a bit and implementing a lot of the HP DL385 dual cores. Pretty smoking boxes for the cost factor there too.
Early on, we standardized on putting 32 gigs of RAM in all of our database servers, and it is something that SQL Server eats RAM alive. And if any performance problems that we were having, a lot of them were significantly solved or at least mitigated by adding additional RAM to the boxes.
Especially when you went to 64-bit.
64-bit was huge for us.
And, okay.
Yeah.
What were you migrating from? Like there's legacy code.
This is the legacy code here was Cold Fusion. Yeah, the question is, are we still running Cold Fusion? And we do have some Cold Fusion on the site, but the extensions won't tell you, because for instance, when we roll stuff out, we can't have two separate URLs to the site, so we map extensions to different services depending on what we're going to use, because we don't like to change the URLs. Opteron, why Opteron? The question is, Opteron is a true 64-bit. It has 64-bit registers in it, and it can also reference a lot more memory with that 64-bit. But Opteron also is a lot more efficient in terms of power usage, and we're able to, with the density that we try to get out of our data center, we look at power usage very closely, so we can get a little bit better density with Opteron.
Chris, you spend a lot of time looking at different 64-bit flavors for the platform.
Yeah, I mean, for us, when we started, we were starting about a year to a year and a half before the server 2003 x64 release was even RTM. So we were coming in pretty early. And at the time, there wasn't a huge, x64 was just starting to spin up, and the only other real option was Itanium. And back then, when we started looking at the hardware, as far as the power demand goes, it was tough to get more than 2 or 3 servers in a rack in the data center. Mm-hmm. So that was definitely a limiting factor for us, where we're charged for space usage in the data centers. And then when x64 started coming out, we started looking at that technology, and the performance of the memory bus as well was really good, even if just running the x86 operating system on that hardware platform. So that really kind of made the deal for us, and we went in that direction. And then Intel started coming out with their x64 offering as well, but we were already starting to deploy servers in our production environment.
Mm-hmm.
Probably slightly beyond the scope of this right now, but the memory bus of the AMD Opteron is significantly different than the memory bus architecture of the 64-bit extensions on Intel. And it's interesting reading if you want to go in and actually sit down and read the differences. There's a lot of differences that affect speed, and for us have affected our deployments of SQL Server.
One small thing, Opteron was also the first one to come out with dual core, and dual core technologies are really great, especially on licensing, with Microsoft licensing.
Oh. we don't have to worry about licensing. Yeah. So one nice thing, we were talking about that earlier too. Really? Yeah. Okay, well, let's go through the next couple, and then we'll get into the upcoming technologies.
Where are we today? We'll go over real quick. At the very top, we've got load balancers. And requests will come through, and it'll hit one of those partition pools that we talked about. You get the dependencies out by dividing up your web farms on the front end. Then the request comes through. It'll hit the cache server. See, is there something in the cache? Yes, great. I don't have to go any further. Let's serve the request back to the user. If there's nothing in the cache, we're going to go hit one of the horizontally partitioned databases at the bottom. We actually use a combination of horizontal and vertical partitioning down on the database side too, just for very separate features that have different performance profiles. So once you hit the database, you can serve it back to the user, but you also should populate the cache.
So let's get into some of the upcoming technology changes now that we're going to go through, and certainly MySpace is as well. SQL Server 2005. So this goes back to the question one of the gentlemen had over here a few minutes ago about going across data centers and keeping your resiliency DR story alive. Our DBA, our database operations team, they're part of the TAP program internally, much like external customers are with Microsoft. Right now, we're very focused on implementing the peer-to-peer replication. Okay, so this is a strategy for, in particular, our place where we host hundreds and hundreds of database systems in a true hoster model. You see there in the picture in the top right, essentially, we'll have n number of database servers that all have the same database same database live, taking read writes across, our back-end network, which, our web servers have commonality between our facilities. What happens is, a customer comes through, request from web server in the first cluster. We don't care which SQL Server responds and takes the transaction. Okay, it's going to get written to it, and then peer-to-peer replication is going to take place behind the scenes. The risk here is certainly it takes time to replicate to the other peers, right? So this model isn't perfect in a situation where you cannot, where it's not acceptable to have a time delay. Time delay to us is what we're seeing right now. Data center A is up in Seattle, data center B is down in the Bay Area. And it takes about 2 to 10 seconds, depending on the transaction, for the replication to complete. That's what we're experiencing. So this, where we use NLB, a lot of people are surprised that we use network load balancing out of Windows, but we use it very frequently, especially on back-end SQL systems or back-end web service clusters. And then we'll use DNS to front that. What this buys us is the ability to pull a machine out at any given time, whether it's patched, whether it's for hardware reasons, you name it. We pull the machine out, it doesn't affect the application experience. Our web engineers aren't scrambling to redo configuration and dependency pointers and configs. So again, that's the model we're using for a lot of our hosting environment internally. The second one, and this is part of the SP1 that hopefully will be approved and released with SP1, I should say. We're part of the TAP program internally in Microsoft, is this database mirroring. And mirroring is really, in that model where I mentioned a few minutes ago, we have a live read-write system in facility A, and it's log shipping, either in that facility or to another location. We're actually eliminating that log shipping step because it takes time to recover. And some of you who have lots of replication jobs and know how much fun it is to recreate those when you fail over and recover, right? I don't know if anyone else is in that situation, but certainly we do. And that's typically what slows your migration down the most. In the case of database mirroring, you have the option to be synchronous and have a witness, a third box in this model. And if you're interested in this space, I highly recommend you keep an eye on, the status of whether it ships as a supported product by Microsoft with SP1, which I believe is going to occur, but I don't have 100% confidence in that right now. And what happens there is if you're in synchronous, you're going to automatically recover. You have the ability to have application failover occur automatically at the app level, and all your replication jobs get recreated and transferred. Right? That's the euphoria from a database hosting perspective. And at that point, we're still doing log shipping, just as another set of resiliency steps to another facility in case we need to go that route, like we have a major outage in that colo. Yeah, question?
The first diagram here where replication is the 2 to 10 second delay that you talked about, replication from SQL A to SQL B, or is it from SQL A to B to C to D?
Okay, so his question is, in the peer-to-peer replication diagram, is that 2 to 10 second latency occurring from SQL A to B, SQL A to C, et cetera? What we're seeing is it depends on in our case, we have about a 20 millisecond delay to those systems that are 1,000 miles away. And certainly the 8 to 10 second range is in the distance transmission, right? Does that answer your question? Correct. Yeah.
Is it 10 seconds to replicate across all of the databases, or is it 10 seconds for each of the replications?
So his question really comes back to, does it take, in this case, yes, if A receives the transaction, it's going to write it to all of its peers, B, C, and D. Within that window, certainly, that 10 second. In the case of B, it's going to get it very quick because it happens to be in the same vicinity, probably on the same switch, right? The 8 to 10 seconds really comes with the fact that we want to go geo redundancy with the hosting model too and get our apps split. So the mirroring, very interesting. We've got 3 systems actually running in production right now leveraging this technology on Microsoft.com. One's using, the TechNet system is using the asynchronous, which is basically, the transactions are being written to the mirror partner. It doesn't wait to receive that transaction is completed before finishing the request with the web host, right? It just assumes it's going to occur. The learning and genuine systems are using synchronous. Table partitioning, we threw this one in there just because it's kind of interesting. Actually, our DBAs came up with this with some devs on a couple big data warehousing systems. And one of them is our stats collection. So we import, billions of records a day from stats on Microsoft.com and other web hosts. And it's expensive to store all that data. So SQL partitioning basically allows us to say, okay, for data that's current, accessed frequently, we're going to put on very high performant disks, right? And that's part of the table partition. Another partition of that table is split off on a cheaper set of disks. And then that stuff that's, we just have to hold for long periods of time goes on yet another cheap set of disks. And that gives us some cost flexibility, some economic flexibility in how we store large data warehouses. We're doing the same thing with our performance and event management collection data off of our operating systems. Right. So Jim's going to get into a little bit of your experience on 64-bit SQL at MySpace.
We've been 100% SQL Server 2005 since November of last year, I believe. We were in the Microsoft TAP program with SQL Server 2005. We were the early adopters of it. We tried it out, and it worked extremely well for us. And what was going to be a slow stage migration became a very quick migration, purely because of the 64-bit capabilities of the 2005 server. For us, we have yet to actually take a look at a lot of the features that Casey and his team are doing with the database mirroring and a variety of other features that come with SQL Server 2005. For us, it's been raw performance gains internally, just to the actual internal storage engine and the internal SQL Server engine, and the relief of a lot of memory pressure that we were facing in our boxes, in our 32-bit boxes with SQL Server 2000. What we would do is we would have 32-bit boxes with 32 gigs of RAM, and SQL Server 2000 would be able to address all 32 gigs of RAM, but we were forced to do it using a mechanism in SQL Server 2000 and Windows 2003 called AWE, which is addressing Windows extensions. And what that does is that enables us to use all 32 gigs of RAM, but only 4 of those gigs of RAM are dedicated to particular memory segments that we were being bottlenecked on. So even though we had 32 gigs of RAM in the server, we could have added another 100 gigs of RAM, we still would have faced in-memory bottlenecks of particular memory pools, because 32-bit architecture doesn't allow you to address those memory pools above the 4 gigabyte limit. What did that mean? What does that mean for us? Well, for us, that meant that our SQL Server 2000 boxes under extremely high load would sometimes just turn off. They would get a lot of connection timeouts. We were maxing out the number of incoming connections and the connection memory pool in SQL Server 2000. So the boxes would go dark, is what I call them, and basically not be able to receive any more connections, and it would require a restart for us. By moving to 64-bit architecture and SQL 2005, even though we still have the same number, we probably have significantly more connections coming to the boxes now, 3 or 4 months later, but because we're able to use a larger memory segment than just the under 4 gigabyte segment with 64-bit, we've completely eliminated the problem. So it's been huge for us, because that was a major problem we were facing with the 32-bit SQL Server 2000.
Nice.
Yeah, and that was actually, we had similar issues that required us to move to x64. When you're putting so much pressure on the networking stack and the kernel, you're really limited to the amount of pool memory you have down there for it to use. So going to x64 really allowed us to start using the memory they had on our boxes to scale up the number of connections, and also to allow the OS to really use its attack mechanisms to handle things like SYN floods and all the different network-based attacks that our servers face on a quite regular basis.
Oh, yeah. Sorry, question?
I'm curious if you guys are doing anything with compiled assemblies, like .NET assemblies, replacement for stored procedures.
The question is, are we using the CLR, the 2005 .NET assemblies and the CLR? And right now, we have not attempted to use that. We have done the conversion. It was a pretty straightforward conversion. We're running pretty much the same code. There's I think there was some changes in some SQL ANSI settings that required us to come back and change some of our stored procedures. But for the most part, it's the exact same code that was running on 2000 is now running on 2005.
We've seen very, very few instances where we had any issues as well in the transition from 2000 to 2005.
It was pretty straightforward.
Yeah.
In terms of running .NET code on your databases, I think if you can avoid it, it's better to split it up. some cases it could come in very handy if you actually need to do some specific code inside a stored procedure. In our case, we don't need to.
For that question, there's an appendix slide in here. There's a link to our blog site for Microsoft.com. I think that'd be a really good question to post out there, and we'll have some internal devs make sure and get you some feedback on their experiences.
Most of our stored procedures are relatively straightforward. We've got very few joins, and they're very simple actually. And for us to attempt to build procedure logic into the database is a scary thought for us.
Yeah, it also adds some complexity as well, because now you're talking about running managed code on your SQL server and dealing with the complexities of the garbage collector and the performance impact that could have on your SQL infrastructure.
Becomes very competitive for SQL, right?
Yeah.
Mm-hmm.
We're going to keep going real quick here. One more question, though? Yeah, sure. Are the slides available? Is that what you said? Yeah. Absolutely. I believe everyone will get a complete copy on ComNet. Thank you. The slides are on ComNet as well. You may know they're videoing all these presentations this year at MIX, and I believe those will be available too. The actual live audio will be shipped out to the attendees. Don't quote me on that, but I believe that's what I heard from someone yesterday.
Hello?
Yeah.
Hello?
Yep.
My question goes that you kind of see, you guys in a situation where you see the water rising and you're putting in the infrastructure to deal with it. But how do you deal with the spike of that? You see this all the time on like Dig and Slashdot when, hey, we got dug, we got slammed. I don't know, maybe with MySpace Valentine's Day or something like that as a spike event where you just can't afford to plan the infrastructure for that
one event.
But what do you do to manage and cope with that? To best prepare for it? You make the best of the situation.
I'll take a shot at that one.
Okay.
They probably deal with, for us, our traffic is relatively normalized.
Yeah.
I know you guys with Update see a lot more flash traffic.
His question was, how do you handle the spikes, right? We might have them from Windows Update releasing one Tuesday every month to marketing releases for a product launch or some sales-driven event. On Microsoft.com, it might be a large security denial of service type spike. We deal with a real variety. And I'll tell you one thing that has saved our bacon over the years is cookie cutter infrastructure. Okay? So we run 100 and some odd internet sites. Every one of those web servers is the same hardware, whether it's a HP DL385 or 585. The operating system builds are the same. If we see a spike coming, if we have a time to plan, actually, we'll do the best job we can to predict the payloads that are going to occur and re-implement boxes from other systems. Right? That's one method. Another method is certainly many people today look at caching vendors and partners to help offload certain portions of their site behaviors and content. In the case of a Windows Update system, there's actually 3 providers delivering that content all the time. Microsoft is a big provider ourselves from our download infrastructure. Akamai provides a lot of that caching, and so does Savvis. Another, for the Windows Update website itself, is, it's actually about 160 servers split up into web farms. And that site is built, right? It's sustained. We know it's a predictable launch cycle that occurs all the time. So there's a spike scenario where, we know we need to invest on a routine basis. And then for the marketing guys, they used to burn us pretty bad, right? And just not even tell us, we're going to release IE next week. And by the way, we put the bits out yesterday, right, or something. So we've just learned our lesson. Microsoft.com, to be honest, it runs about 30-40%,
right.
On a typical capacity basis split across data centers. So if we get burned by some event that we didn't see coming or some payload, we might run 50-60+%, which means we're at risk from a resiliency perspective if we go dark in a facility. Those are all scenarios that could happen, but hopefully that addresses some of your question. It is a hard problem.
In extreme situations, it's good to have some knobs on your back end. If, let's say, there's a particularly heavy feature, and it's the choice between bringing your site down or turning off a feature, it's good to have
Yeah,
things like
there's
that.
another tactic.
Yeah.
Right? Ours, though, cookie cutter infrastructure, repeatable, reusable hardware, right, has been a nice blessing for us.
Yeah, we have mirrored colos, and we can turn both on. You know, we're running,
Yeah.
major ads or whatever. Like, I don't know.
So having resilient infrastructure that you can light up in other colos or other facilities, absolutely. Good. Hey, go into this real quick, guys. And you know what we're going to do? We've had a lot of questions throughout the whole session, which actually we prefer, right? And this is great. So we probably won't have a lot of time just open, formal open panel, right, over the next, say, 10 minutes or so. But let's just keep going through the slides, and we'll keep going through the dialogues that pop up. And when the session actually gets over, it's the last one of the day, so we're going to stay as long as anyone wants to hang out and chat, right?
We've also got some cool stuff up here for people that stay.
You do?
Yeah, goodies.
Yeah. We just have a handful more slides, right? So we'll keep rolling with it.
Virtualizing storage. For us, the number one word has always been scale and scalability, and how are we going to scale this thing? And the three things that came down to, for us, on a scaling level is one, we talked about earlier, a horizontally scalable architecture and infrastructure. Two, 64-bit, which makes for a vertically scalable memory addressability in each individual server. And finally for us was horizontally scalable storage, the ability for us to scale our SAN infrastructure in the exact same way that we scale our server infrastructure, which is in 1 million user segments. So what we did is we brought in about, I think 4 or 5 months ago, we brought in every major SAN vendor that we could find. We had them bring all of their SANs to our data centers, and we ran production load and moved all of our users onto all the different SANs and just did a large-scale bake-off of all the major vendors. And what we found was that the new technology now that enables us to what we call is virtualization of storage. And what it is, it's a software layer that sits above your RAID controller and in between your HBA. And what it does is it allows us to provision storage in such a way where instead of having your old RAID 1 mirrors, your RAID 10 mirrors of 8 disks, 14 disks, 30 disks, every disk that sits in our SAN infrastructure is able to accept writes and reads from any piece of data in the entire environment. So by having 3,000 disks in our SAN storage, we actually have stripes across all 3,000 disks. It's actually more like 1,000, but stripes across every single disk in the SAN infrastructure. So a log file for SQL Server that could be hitting with a large amount of load because we're having some flash traffic or something's coming in and we're running a large-scale SQL checkpoint operation that in the past in our old SAN infrastructure would send a large amount of IOs to maybe a subset of 10 to 15 of 20 disks in the SAN environment, would max out those 15 or 20 disks. Right now that's now spread across all of the disks in the environment.
Very cool.
As we add more disks too, we also are able to just stripe. If 1,000 disks are maxing out, we can add another 500 and easily stripe. The 1,000 stripe becomes a 1,500 disk stripe.
So it's not a solution everyone needs to worry about, right? But if you ever get to that scale, that's cool. I mean, very cool. Yeah, question?
I didn't hear.
Can you repeat that?
Speak up.
Well, when you're adding and expanding your disks.
No, we were able to do it in real time.
It works. It's a completely different technology. It actually uses something called chunklets, and it's able to move those chunklets around and spread them across the disks. It's because it's not traditional RAID. There's actually software controlling that there.
So what happens if you have a disk?
You actually have chunklet failures, and it's actually individually segments on the disk fail, and if an entire disk fails, all of the chunklets on that disk fail, which are dynamically reallocated.
Cool. So this is, we only have a couple slides left, and then Chris is going to show a quick demo of some debugging type tools that are going to ship with IS7. Right now, our team back at home, in Redmond, Washington, is very focused on Longhorn and IS7 adoption. Seems crazy because it's a year plus out, a year and a half out or so.
Longhorn
but
server.
believe it or not, 3-4 weeks ago, we actually put a Longhorn IS7 box in production on Microsoft.com.
And it lasted a few hours.
We actually had internal bets going with the IS team, right? We had a pool of who would get closest, and our debug manager won, but I think he had the inside scoop. But the reality is, these are the core scenarios that we're going after. They're very commonly heard from folks like MySpace, other people that we talk to. UNC Content Store. This is all about. Microsoft.com has over 100 gig of content on every server. It's the same content on all 80 servers, right? And that is not the most enjoyable thing to try and keep in sync, to try and replicate that data. There's over typically 2 to 5 gig of change a day occurring over that 100 gig in aggregate. We will love the day when our dynamic site can point back to shared large store files, file storage of that content.
Exactly, and also in our download scenario as well, where it's a tougher challenge because the download servers are hosting 2 to 3 terabytes of data per server. So the costs there for disk usage is really high.
It is. It's a real pain for us. It's an economic pain and it's a management pain, right? And like Chris said, if you ever go to download.microsoft.com, there's actually over 2 terabytes worth of content there. Windows Update or Microsoft Update Now, that's a separate content store, and yep, it's grown quickly to that 2 terabyte plus range. So that's some challenges we have. We also store lots of media, streaming media, downloadable media. They're growing like crazy, and we have demand coming from all over the country, all over the company to do more hosting in that space. So we've got to prove this scenario and make it work. And the IS team's very committed to this with us. File replication, data center. We haven't talked much about this currently, but Chris, they made some changes to the TCP stack, right, coming out in Vista as well as in Longhorn.
So some really cool changes that are really going to help us out.
Help everyone out.
Yeah, help everyone out in their infrastructures. Mainly in the Vista client, where we now have automatic window scaling. That's significantly going to help throughput over really latent links.
What we've seen specifically is we've been testing Vista clients hitting our download infrastructure from 4 different locations around the world, and those long distance latent links, we're seeing like 200+% improvements on download rates. So this kind of opens the door as to when you're thinking about your dynamic features. There's a new rich platform that's going to make the performance a little better too.
Yeah.
And on the server side, you run multiple colos, multiple data centers. It's always a good time trying to move data across these links. They might be thousands of miles apart, right? We used to be restricted on how much could be delivered at any given time from a host, right?
Right. So we ran some tests across our back-end network between our data centers in the Puget Sound area and in the Bay Area, where we have 20 milliseconds of latency, which is nothing really. And using server 2003 to server 2003 transfers, we could get maybe 10 to 12 megabits a second. But with some of these new changes
these are out of gig NICs.
Right, these are gig NICs with multiple OC48s between the two locations, so plenty of available bandwidth. And with some of these new changes, we tested 2 Longhorn servers over that same link.
Because Longhorn has the send window.
Right, it has the larger send window, and there's some new congestion avoidance algorithms that make the stack more robust to dealing with packet loss that happens over those types of links. And in that scenario with Longhorn server, we were able to push 850 megabits from server to server, where we almost pegged out the NIC. So it was really exciting, and it really opens the door for us to start looking at hosting in more international locations where latency can be a problem.
We all have the pressure from the execs above to do things, make the site never go offline and do it cheap, right? And that's the challenge that we play with. Making it never go offline certainly helps if you have the tools, the abilities to ship from colo or data center to data center. Right? This is going to be certainly one of our tools there. IS configs, you guys ever messed up a config on a box within your clusters or your sites, right?
Yeah.
We are equally as guilty, right? I mentioned earlier, on Microsoft.com, we're very disciplined. We have this script that has every setting, right? Any change that goes out gets put in that script, tested, delivered. Well, they moved to like a 3 config file model in 7.
Exactly. Having to deal with the metabase is gone. You now have web config, machine config.
Let's hear it for that, huh? I know there's an IIS guy in here that is hearing this right now. So,
So you've got your 2 config files for .NET, and now the IIS config is all stored in a single XML file, and there isn't anything that's machine specific in that file, so it's your one file for your site, and you can
so you make a change in the UI, you make a change from a script, whatever your approach is, they're all going to be captured in somewhere within those files, right?
Yeah.
And they're completely copyable from host to host.
Right, and the nice thing with IS 7 too is that the APIs for accessing the metabase still work in 7. So if you have heavy dependencies on ADSI or whatever you used previously, it just works, and your config changes go into this one single XML file.
That's cool.
Yeah.
It's been asked for a long time, and IS guys, I think, are going to deliver for us this time. What's that?
It's a blessing.
It's a blessing. Yes, that's right. The dynamic content compression, here basically, this was delivered in a more mature fashion with IS6. We tried it out. Our content is highly dynamic on Microsoft.com and many of the sites we host, and it was a pretty good perf hit for us. So we actually haven't been able to run it. I think they're doing a little. Yeah, there's a question there.
Sorry, you mentioned a lot there about standard hardware. I was wondering what would be your standard hardware in relation to a NIC? Have you any experience using TCP offloading engines for high traffic, especially with the at the edge of your network?
Yeah. So the question is, do you ever look at, from a hardware infrastructure perspective, at the NIC or offloading any of that traffic to other hardware devices?
Right. And I guess, we're also testing with some of the newer technologies coming out for Server 2003 that's shipping as, it's called the Scalable Networking Pack. And there's some receive-side scaling stuff there that allows the NIC to properly use all 4 processors in a box instead of 1. So we're definitely looking in that space for our downloads business.
How about as far as actually offloading it to an off-the-box device or some of the payloads? Anything? Do you guys do anything?
Not really.
No.
For networking or HTTP or? Right. Mm-hmm.
Just wondering, from Microsoft's perspective and from yourselves, as your backend, how you use tools or the
Yeah, for MySpace, we've never used any type of TCP offloading equipment. Our load balancers do some of that actually on HTTP. They can do multiplexing so they can handle all the client connections and then keep persistent connections to the servers, which really reduces the amount of TCP connections down on the server level too. NetScalers, yeah.
We use network load balancing out of Windows, and in some cases NetScalers as well. Yeah. So last one here. Chris, why don't you fire up the demo? And as you're getting ready for it, or actually go ahead, yep, if you're ready. Okay, this is basically, we want to just show you a glimpse, okay, at some diagnostic tools that are shipping with IIS or are expected to ship with it at this time. The screen might flash a little bit as we convert here. But essentially, we often hear, what's happening inside that black box of IIS, of your web server, Microsoft. Right. And unless you've got a team of smart guys like Chris and our debug group who can actually break into user or kernel mode and get to the guts of what's happening, it is a black box at times, right?
It's hard to figure out what happened to a request. Why did it fail? What happened inside IIS that caused my request to fail?
And the IIS logs aren't bad. It tells certainly a story of what's occurring, right? You have a server performance advisor,
right?
SPA, right? That people can download, but it's a little bit difficult to configure. It's a lot of data that gets collected.
Right.
Certainly a useful tool if it's if you have those kind of issues.
Yeah.
But show them this.
So real quickly too, in Server 2003, the data is there. It's exposed through ETW APIs, and you can get to a lot of this information. But like Casey was saying, it's hard because there's a lot of data, and you have to figure out how to parse these logs to find what you're looking for. So what they've done in IIS 7...
This is the UI for 7?
Right, yep, this is the new management console for IIS 7 here. And so what they have is failed request tracing, and what that'll do is it'll create an ETW log for you based on parameters that you can configure in IIS. So it'll just generate the piece of ETW information that you need in a single file that you can go and look through afterwards. So what you do here in IIS, I can go into the failed request tracing section and define a new rule. And so in this rule, I can choose what type of requests I want to trace on, whether it's all content, ASP.NET specifically, or just a specific URL. If I only care about a particular application, I can do that. So I'll just go ahead and choose all content here. And then you can define another layer, which is the types of HTTP status codes that you want to generate logs for.
So you're essentially filtering on error codes.
Exactly,
codes.
exactly. So you could say just 500 errors or 403s, and you can also specify, just how long the request took. So if I've got a request that's taking 30 seconds or 60 seconds, IIS will generate one of these trace reports to give you information about where it was hanging in that request path in IIS. So you just throw in some status codes here. And then you also get to choose the trace providers that you want. So what kind of data are you interested in, whether it's ASP, ASP.NET, or the core IIS itself. And they also break it out into all the different modules that your request is going to traverse through to get information on. And then you just create the rule, and IIS will take care of generating these reports for you that you can look at. So as a scenario, what I've done I ACL down a directory in IIS so that when the user goes to it, they're getting a user prompt. So how do you troubleshoot that, right? I mean, in your logs.
Yeah, has anyone ever had an app that had some kind of failed authentication, and you're sitting there looking at the IIS logs going 403 or some 400 code?
Exactly.
And you're scratching your head as to, okay, now where
why,
exactly
right?
is this failing?
I've got a 403 in my log, but why? And so this is what one of these reports looks like.
So this is the output report that would get generated?
Yeah, exactly. And so it has just a ton of information that's really useful. It's actually just a raw XML file, and in this case here, there's an XSL file that's doing some of this formatting here. So if you wanted to, you could do some parsing on that XML, on that raw data. But right here, right off the bat, it shows us detail highlights, unauthorized, error code access denied. And what you can do, so that just kind of points out where the problem is, but what you can do is you can go down and looking at some of these events, right? General request start, filter start. So it's stepping through each of the modules and giving you information about what happened in the request path as my request to the web server came in. And eventually as I scroll down here, I'll see...
We're going to a little better of a white box mode for the web server platform.
Right. So you can really see in detail what happened with this request. And so I go down to the error here, and it's my unauthorized error. And if I look at the two previous events, I can see right here on the file cache access start event, it shows me right here, dhttp-freb was the directory I was trying to access as internet user. And it says right there, right, access denied on that physical folder. So there's a lot more information.
So right there, you know that account doesn't have the right permissions on that file path.
Exactly, and
that's your authentication failure.
Right. So it finally gives us a method of, okay, something's failing. How do I figure it out without having to hook up a debugger? Trying to jump into the debugger and break into an IIS.
So maybe we don't need you anymore?
Well, I wouldn't go that far. But it's great, right? Because it gives engineers a chance to say, what went wrong in the application. And with this failure model, it also gives developers a chance to put their own eventing into this, to tie it in here so that they can put more trace information from ASP.NET into these files for operations engineers to go in and
the cool thing, this actually you can set up to run all the time. Right. So it's always looking for those HTTP status codes or your filtered events that you've defined. You don't have to sit there and run log parser against your logs over and over and try and rip out the data that's of interest. Very, very good stuff. And hats off to the IIS guys. They might do this for a second. They said so. Right. Hats off to the IIS guys for putting that together. Right. A quick question, yeah.
ASP.NET stack traces show up in that as well, or do you have to capture that somewhere else?
I believe that
will ASP.NET stack traces show up as well?
Right, will they show up in there? And I believe the way that you can hook into that is through the trace.write and APIs in ASP.NET, so you could put custom data into that into that event, basically. So if you wanted to capture the stack and do a trace.write, you could stuff it in there.
So we've got one more slide. This is the last one, and then we'll stay and take as many questions as folks want to handle.
If you guys want to come pick up a shirt too over here,
Yeah.
we'll be giving those out.
We thought we'd throw this out. You know, it doesn't have anything to do necessarily with the Microsoft product or you know what MySpace is doing right this second, but the reality is there's a lot of dynamic, very cool traffic shaping technologies going on the internet right now. One of them that we just implemented actually this week on Microsoft.com is some kind of geo-targeting solutions. So we wanted to have the richness of targeting at a locale level. It might be country, might be state, might be city in some cases. Different application or content experiences depending on where they reside, their locale. Okay, and what happens behind the scenes is this is a solution that we use from Akamai to partner up. They're not the only player in this game by any means, but we have relationships with our caching, so they're a partner that we decided to go with. Essentially, we have policies that we define what volumes of traffic we want to send to these different locales. That helps regulate how much traffic goes, whether it's 100% or 8%. So we might not say want to push everything as fast as possible to a region. As well, we can look at some other demographic type features like distinction between narrowband and broadband clients or users, right? In our case, we're always trying to manage our bandwidth. Bandwidth is our #1 operational cost for our Microsoft.com operations, okay? The harder to reach narrowband users, we never want to bottleneck or restrict their experience because they kind of do it on their own, right? The broadband market, though, is huge, and certainly this gives us some flexibility to understand those clients and potentially handle those experiences differently. So I just wanted to share the fact that this kind of technology is out there. We've got a lot of devs internally thinking about how can they affect the richness of the personalization and richness of the client experience based off technologies like this. From that, we're going to move right into any additional questions that you all have. Yeah, there's one right there. And before I go into that, one last thing. There's several appendix slides. We cut a ton of content between MySpace and Microsoft.com. It's all in the appendixes. There's some slides there that we have for Microsoft.com that outlines a number of white papers, online webcasts, TechNet articles that we've written up about 64-bit, lots of hosting type related issues. And lastly, there is a blog site there. I mean, you're by no means going to get every question answered today. You're going to walk away and think like, oh, God, I wish I would have asked that or this. Feel welcome to just shoot it out to that blog site, and we have people monitoring that on a regular basis, right? So thank you very much. Again, feel welcome to stay and ask any questions. Great. In the back first. He's been
also,
waiting
come
for a
up
while.
here before you leave, guys.
Yeah. I think we got you, yeah. So his question really comes up, yep, come up and get your T-shirt. His question was really about, well, we talked a lot about hardware, standardization of hardware, high scale, 64-bit with lots of memory. Where's the balance there in having performant software application development, reworking back and potentially re-architecting or re-engineering your application versus the more robust hardware solutions? Is that fair? Yeah. Essentially, I'll speak for us at Microsoft.com. We work in partnership all the time with our development, test, and program management organizations. So we're always consulting, if you will, peer-to-peer, looking at the current infrastructure and applications that are hosted. And if we have hotspots, the first thing that we jump at is not hardware, right? We always go back and look at what can we do from a performance impact on the application.
Right. How do we tune the OS?
How do we tune the OS? How do we tune ASP.NET? Are there perf-related bugs that we should be looking at? with the application itself. Hardware is always one of the last solutions for
Right,
us.
and that's exactly why we're running Longhorn a year and a half ahead of schedule as well, right, to hash out some of these potential issues.
Yeah. Thank you. Good question. One sec.
I have a couple questions.
Yeah.
So the first one is, do you make any use of SSL accelerators at all?
So the question is, do we use SSL accelerators? And the answer is we don't. We actually, we did quite a few different kind of, I'll use their term, bake-offs. We had some accelerators. A site like Windows Update is almost 50% SSL traffic, for example, all through ASP.NET, very dynamic content and requests coming through. With the hardware performance that we have today, we didn't see the benefit from an economic perspective of going to a device or an off-the-box accelerator.
Right. I'd also add to that too, in Server 2003 SP1, there's a documented reg key that you can set to handle SSL offload directly in HTTP.sys. So you end up allowing HTTP.sys, which runs in the kernel, to handle your SSL connections, which is very efficient.
If you want to come up and get that, we'll also post it out on our blog site for people that didn't hear that. But essentially, there are registry config settings that can help make that more performant, SSL more performant on 2003.
Okay.
And this is Thomas from the IS team. He says it's going to be default in Longhorn.
Oh, excellent.
Yeah.
And the second question was, they mentioned there were 60 Dart servers on the MySpace area. Do they run their own ad management servers?
Do they run, I'm sorry?
Do they run their own ad management servers?
Ad management.
Yeah.
Good question. So does MySpace run their own ad servers? Does MySpace run their own ad servers?
No, we do not.
You have 60 Dart servers?
No, we run our own ad servers. We use Dart, which is DoubleClick's ad software. We don't have our own ad software, but we run our own ad servers.
Gotcha.
So you host the solution?
We host it. Yeah. Correct.
Hi, my name is Pradeep. I have a question for the MySpace team. Basically, you have this
hey, Jim?
the caching tier. Can you give a little more information? Like the caching, are you just using the ASP.NET 2.0 caching, or did you add anything extra?
We were looking at using the caching objects built into ASP.NET. We moved away from that, and we've actually written what we call a dumb cache, and it's basically an in-memory object store. So anything from our presentation layer to our database layer can send any type of serialized information to these ASP.NET servers, which take the information. Actually, it doesn't need to be serialized. The servers themselves do the serialization. Take the information, store it in memory based off an LRU, and then send it back whenever it's requested. So we can store any object we want. We can store in the caching tier. It's very simple, actually.
Okay, got it. Thank you.
My question is slightly related to his. Have you guys looked at any of the database change notification stuff in SQL Server 2005 for your caching? My experience has been that just kills scalability.
The change, where the 2005, when I change a record, I can then go out and pop my .NET 2.0 cache.
Right.
We initially looked into that, and what it seems like it's good for a type of application of, let's say, a product catalog, where I'm updating my product, cost of my products on a nightly basis. Anytime you get into extremely large scale, hundreds of thousands of transactions per second, it doesn't scale.
Okay, that's my same experience. That's what I wanted to see. Thanks.
Yeah.
So how do you communicate with your cache service? Is it a web service?
Yes, my first question is about load balancing.
The presentation layer has
use
every server on the
software,
presentation.
hardware, or some combination of both?
So for Microsoft.com load balancing, we run network load balancing, NLB, for almost every website we host. There's a handful of them that we run NetScalers in front of. In the future, to be quite honest, we're getting a lot of application requirements, session state requirements, some caching type requirements. We're going to be further adopting our NetScaler implementation.
And that's hardware or software?
Hardware. That's a hardware solution, yes. Yeah.
The other question I had, when you need more physical servers due to demand, how do you replicate the server OSs?
So what was it?
In other words, do you clone them? Are you using virtualization of servers, or do you just manually build more servers?
Okay. So how do we build our servers? Yeah. we use Altiris imaging for the base OS image. And then we, on top of that, have a scripted install for our SQL and also for our IIS platforms. And then a third layer, essentially, which is the application config, which would be like the Microsoft.com configuration or the msdn.microsoft.com configuration. That's a VBS script that applies all the registry, config, metabase, application content type settings.
So essentially, you run a giant script.
Yeah, that's fair. Very fair. Yeah.
Okay, thank you.
Yeah.
How you doing? I have a
Good.
question on networking with an all-Windows website. We have an issue where we separate our network out external versus database traffic versus administrative traffic on multi-homed separate network cards.
Okay, so you're running 3 NICs?
Correct.
Yeah.
There's a push in my organization to move down to 1 NIC for any server. This is, of course, a server that's going to be part of the Active Directory. It's going to have file shares, everything else, but every server would have one network interface card.
Yeah, yeah.
Can you see any problems with that, performance related or?
Yeah, actually, that's a really interesting question, right? We have this internal debate all the time. Question is really a single NIC architecture versus an n number of NICs for back-end database traffic, administration traffic, or your HTTP traffic, right?
Right.
And there's risk in a sense. I'll be point blank. I don't like the single NIC architecture, right? It's certainly not my preference. If you ask our network engineers, they like the single NIC architecture, right?
It's the same.
It's certainly a reduction of ports, more complex ACLs and management on their side, but less infrastructure potentially, lower cost potentially. One of the biggest risks that we have for Microsoft.com is if you single NIC, if we get under attack or we go offline for any reason, that box is dark to us, right? For all remote management, and we're dead. Right? Same thing would be if anything on the front end negatively impacts the performance of that NIC or that interface, all your administration and your back-end application dependencies are impacted as well. So that's just our experience in the topic.
Okay, thank you.
Yeah.
Hi, Casey. Quick question.
Can you speak up just a little?
Sorry. Do you use Microsoft Content Management System services?
Do we use CMS, Content Management System? On Microsoft.com, there's the TechNet architecture uses the CMS, the Content Management Server product. I will caution you, though, they did a lot of custom development on top of the data store and API layers. So it's not an out-of-the-box CMS installation.
Okay.
But they are using that today.
Do you expect to move to SharePoint?
Do I expect them? Not. The question is, do we expect someone to move to SharePoint? Like them, for example. They're not actually. They're rolling their own new content store for their system.
Why is that? Is it performance?
It wasn't a performance factor that I'm as aware of as much. Probably the best way to handle this, if you go to our blog site, or if you come up, I'll give you my email address.
Okay.
I'll just put you in touch with the folks that are making those decisions, so you can have that discussion. Yeah. Because operationally, I probably wouldn't be the best person to answer that. If you email me that question, I'll make sure the right people get in touch with you. Thank you. Yeah. Yeah.
2 questions. Do you use session state at all?
Do we use session state at all?
And if you do, how do you balance it?
Very little. Microsoft.com, there is no session state. Okay, so it's not much of a requirement for us today. We have a handful of sites, certainly, that are using it.
So the ones that you do, that you load balance across different servers, what are you using in that?
They're using NLB, right?
Okay.
So, but they have a pretty lightweight session state demand, right? They're not being very rich about the usage.
Right.
We're anticipating quite a few changes in the near future, and to be quite honest, we're going to be expanding more than likely our NetScaler implementation.
What are you thinking of using at that time?
NetScaler.
Oh, NetScaler.
Yeah.
Okay.
Yeah.
Okay. Good. The other question is IIS replication. Do you do that through your script, or do you have some way that you push it across?
Yeah. For IIS replication, we do that through the scripting management.
Okay. So you just write it once, and then you just hit all the boxes individually.
Yeah.
You never replicate.
Correct. We don't use the replication to send it across the different hosts.
Right. Yeah. Okay. Tell me one more time. NetScaler is the the product you're saying you're looking into for the state server.
Yeah, and it's by no means the only one, right?
Right.
I mean, Cisco's got solutions, F5's got solutions. There's a number of them. And we already have some NetScaler implementation, so we're already familiar. Our management and monitoring is using it, so we're going to expand on that model. It's worked for us.
Okay.
Yeah.
Thank you.